Hi everyone, we're going to review natural log and then talk about how to differentiate it. So we're going to start with the actual definition of natural log, which you haven't seen before, and we're defining it as the area of my reciprocal function, 1 over t, from 1 to x. Okay, so whatever x is goes here. Okay, and this should look pretty familiar. It looks a lot like your second fundamental theorem. So if I want to differentiate natural log, I would really be differentiating an integral from 1 to x, okay, which is an application of our second fundamental theorem of calculus. So we're moving on, we learn about Euler, where Euler's number comes from, which is E. Okay, and let's talk about some properties. So hopefully you remember some of these, domain and range. Okay, so I go from 0 to infinity, not including 0. You cannot have natural log of 0, that's a no-go. You can have natural log of any positive number, but 0 is no-go. Okay, so my graph. If you do not remember what the graph of natural log looks like, just think about the graph of, okay, that was horrible. The graph of my exponential function. That's still horrible. Let me try that one more time. Okay. The graph of my exponential function, okay, it crosses the y-axis at 1. If you know what a function looks like, then you know what the inverse of that function will look like on a graph. Okay, you just reflect it across y equals x. And so my natural log will look like this. And it crosses the x-axis at 1 instead of the y-axis. Right, so this is my natural log function. Okay. Some other properties that we've talked about before are expanding and contracting or combining functions. And then the big one is that if you have an exponent on the inside of your natural log, you can bring that down to the front. Okay, so let's practice expanding. So first thing I'm going to do is I see that I have a division sign. So I know I can split this into two natural logs that are subtracting. Right now, it's a good habit to write absolute value signs instead of parentheses. So that's what I'm going to do. And I'm going to go ahead and take this 2, this exponent, and I'm going to bring it down to the front. Minus natural log, I have x squared plus 1. Oops. And all this is to the 1/3 power, so I'm going to bring it down to the front. Right, that's it. That's all we can do. All right, now I'm going to simplify my expression. I'm going to combine everything in a single log. So I see that I have a plus sign, so I know I'm going to multiply them. And furthermore, I have these exponents in front that I can bring up. Okay, so I'm going to take this 2, bring it up to the top here, take this 1/2, bring it up, and I'm going to go ahead and multiply these two quantities. So I have natural log of x plus 3 squared. You could do a square root here, but I'm just going to write x minus 2 to the 1/2 power. All right, let's talk about derivative. So the derivative of natural log of x is 1 over x, and you probably could have guessed that from the definition we gave right here. If you did the second fundamental theorem, you remember you just kind of do a variable swap, you just get 1 over x. Okay, that's pretty easy to see. So the derivative of natural log of x is just 1 over x. Okay, now if we have a function, okay, so like natural log of u, where u is some function, you have to remember to do chain rule. So you're going to do the same thing, whatever's on the inside of your natural log, okay, you just put that in the denominator, okay, 1 over that. Then you have to multiply it by the derivative of your function, okay, whatever u is. A really, in my opinion, the easier way of thinking about it is it's just u prime over u. So the derivative on top, the original function on bottom. Okay, we're talking about whatever is on the inside of your natural log. Let's practice that. I have natural log of 2x. So the derivative on top of 2x and then just 2x on bottom. So the derivative of 2x is just 2. What's inside my natural log? 2x. All right, let's try it again. Here I have x squared plus 1 on the inside of my natural log. Well, I'm going to go ahead and do my bar. X squared plus 1 goes on the bottom. The derivative of x squared plus 1 goes on the top, which is just 2x. Okay, that's it. All right, now I have a product. So let's do product rule. A derivative of the first is just 1 plus, this time x times the derivative of the second, and the derivative of natural log of x is just 1 over x. We can simplify this a little bit. And we're done. Okay, now I have a slightly more complicated function. Okay, I have natural log of, I'm going to write this as x plus 1 to the 1/2 power. And I want to find f prime. Well, again, we just make a big division bar. I'm going to put x plus 1 to the 1/2 power on bottom, okay, and take the derivative, stick it on top. So the derivative of x plus 1 to the 1/2 is going to be 1/2 x plus 1 to the negative 1/2 power. Okay, we could reduce this for sure. We could definitely reduce this. So I'm going to go ahead and take this and treat it as a denominator. So I have 1 over 2 times x plus 1 to the 1/2 power times 1 over x plus 1 to the 1/2 power. So what happens when you multiply two square roots with the same insides? It becomes whole. So I just end up with, okay, I almost made the worst mistake of all time. 2x plus 2. Okay, and one more right here. I have natural log of x. Well, okay, let's just break this down. So this is the inside of my natural log. So when I take the derivative, do my division bar, the inside of my natural log goes on the bottom, the derivative goes on top. Okay, don't overthink it. Definitely don't overthink it. All right, and just a couple more to finish out these notes. Okay, so again, I have natural log of x cubed, that's on the inside. So x cubed goes on bottom, 3x squared goes on top, we reduce. Okay, this one is, we're going to start with power rule. Okay, so I have something cubed, so we drop the 3 down. And it's going to be important for you to remember these parentheses, okay, because it's not this, it's this. Okay, so it's on the outside of everything. That's why we want to make that distinction. So it's going to be important for you to remember those parentheses. Okay, so we have 3 natural log of x squared times, now we do chain rule, so the derivative of the inside, which is 1 over x. Right, just some practice. Okay, I want to show that this situation is a solution to this situation, this differential equation. Okay, well, we can do that using a substitution. Now, the only problem is I don't know what y prime is. Okay, I have y. I know what y is. I need to know what y prime is. To find y prime, I'm just going to differentiate. So we've actually already done this. Okay, I know this derivative. It's natural log of x plus 1. And then minus 4. So it's just going to be natural log of x minus 3. Okay, so this is my y prime. Now all I'm going to do is substitute what I need to into this statement right here, this equation, and I should get 0. Okay, we're just going to prove that I get 0. So x plus y is the same thing as x natural log of x minus 4x. Okay, so I'm going to make that substitution, minus x times natural log of x minus 3. And all this should equal 0. Right, so let's make sure. Let's go ahead and distribute. So I have x minus 4x there, so that's going to be negative 3x minus x natural log x plus 3x. Well, look, everything cancels. I get 0 equals 0, so I know that I was right. Okay, so I did indeed show that this is a solution. The reason being because this, I guess, validated this equation right here. All right, that is it for this. I will see you all later.